All right, so for problem one, we have a study of road rage that asks separate random samples of 596 men and 523 women about their behavior while driving. Based on their answers, each respondent was assigned a road rage score on a scale of 0 to 20. Are the conditions for performing a two-sample t-test satisfied? Okay, so let's recall what they are. The conditions are, remember, the random condition, the 10%, and then the normal large sample, since we're talking about an inference dealing with means. So the random condition, we're told that we have separate random samples of men and women. So that's met. 10%, we can say that, this is definitely, these numbers are definitely less than 10% of their population of, all male drivers and all female drivers. So we can say that's met. And normal large sample, either we're told that the population is about normal, or our sample sizes are at least 30. Both our sample sizes are at least 30. That's what most texts use. I know some other texts may use 25, but in either case, our sample sizes are each large enough, so all conditions are met. So let's go through each one. So we don't need to check for normality. That's not going to be A. We don't need to check for that because we already have third condition met. That takes care of that. Range score between 0. It's definitely not no because conditions are met. We don't know about we don't need the population standard deviations for this stuff. Yes, the normal large samples guarantee the corresponding. No, it's not necessarily going to guarantee. It's basically if one or the other. If you're told that the population is 30 or larger, I mean, if you're told that the sample sizes are at least 30, or if you're told that the distribution's normal or about normal, you can go ahead and proceed. It's not that this guarantees it'll be normal. Sometimes it will, but it doesn't guarantee that. That's like a trick question, a trick answer. And so then our answer is going to be E. We have two independent random samples and large sample sizes. So E is our answer. Right. Problem 10.2, we got 35 people from a random sample of 125 workers from company A admitted to using sick leave when they weren't really ill. 17 employees from a random sample of 68 workers from company B admitted that they had used sick leave when they weren't ill. A 95% confidence interval for the difference in the proportion of workers at the two companies who would admit to using sick leave when they weren't ill is. Okay, so if for some reason you kind of have trouble memorizing or remember exactly the form of confidence interval, it's in your formula packet, but not straight up and like telling you exactly what your p hat and your standard deviation and all that. It's given in this form. So we're given our statistic plus or minus a critical value times the standard error of the statistic. So we have our confidence interval. Okay, so our statistic. Remember, trying to estimate the difference in proportions. So our statistic, we would have basically either P1, either the proportion of company A minus the proportion of company B. That'll be like our point estimate or our statistic. Plus minus our critical value. Our critical value, since we're dealing with proportions, is going to be Z, a Z star, times our standard error. Let's look at what we got going on here. So we have on this, we have the standard error of the sampling statistic, and that's if we're dealing, for the difference, if we're trying to find the difference in populations, the population proportions, P1 hat minus P2 hat. So we're going to just use this form. Our P1 will be the population A and P2 will be population B. So this would be PA times 1 minus PA hat over the number in sample A plus PE hat times 1 minus PB hat over the sample size in B. Let's look that over. It's squeezing it in, but there we go. So let's go ahead, let's figure out what these are. Let's figure out what these P hats, what the P hats are. So for this we have 35 from 35 people from random sample of 125 from company A. So our P hat A, a proportion for company A would be 35 divided by 125, which would be 0.28. PA is 0.28. Our proportion in sample B would be 17 over 68. 0.25. And our Z star, we're talking about 95% confidence. So remember, we're looking at essentially the normal distribution where 95% is in the middle, or there's 2.5% to the right and left of the endpoints. So Z star, if you calculate it or use your table or use your normal or use your calculator, you're going to find it's about 1.96, a little bit less than 2. And you know that from the 68, don't forget the 68, 95, 99, 7 rule. And which says that 1 standard deviation away is about 68% of the distribution. About 2 standard deviations away is 95% of the distribution, or be more precise, 1.96 standard deviations away. And 3 standard deviations away would be almost the entire almost the entire distribution, 99.7%. So our Z star would be 1.96. And all that's really left to do now is should be under square roots, is just fill everything in. So our confidence interval will be, so PA 0.28 minus 0.25, that would be 0.03 plus minus our Z star 1.96 times the square root of P, the sample proportion for A, P hat A, 0.28 times 1 minus 0.28, or 0.72, over the sample size for sample A, or for company A, is 125, plus the sample proportion for company B, which would be 0.25, and 1 minus 0.25, 0.75, over the sample size of company B, which is 68. And let's look at which of these match that. And then, so then our answer would be B. All right, so there you go.